So here is a simple output. On the top, what you see is a simple request that was generating uses a Postman client on Chrome browser on my machine, and then the response that was generated by the WildFly server. Um, all I wanted to send was hello world, 11 bytes, but for those 11 bytes, there was 663 bytes of data that was exchanged back and forth between the client and the server. So that's a lot of overhead. And again, as I said, it's okay if you're sending only a few messages a second. This may not be noticeable, but the moment you get into the scale where you're sending lots and lots of data, lots and lots of messages, this certainly becomes a potential bottleneck as well. So how WebSocket solves it? Well, first of all, WebSocket is a bidirectional protocol. What that means is the client can talk to server, client can send a message to server, and server can send a message to client. So that makes it bidirectional. It's not just client driven. At any given point of time, they can talk to each other. There is a full duplex protocol. That means they can both talk to each other at the same time. There are no predefined message exchange patterns, so to say, that client sends a request and server responds. No, it's a client sends a message to server, server sends a message to client, and they act upon it or they react upon it. That is up to them. It's a very lean protocol, as opposed to the verbose part of HTTP. The WebSocket protocol itself defines, it's really a 2-byte overhead in terms of how the framing is being done. There are none of those cookies, HTTP headers, date timestamp, all of that. None of that exists in the WebSocket world. And the best part being, it uses the existing TCP connection. So once you establish a HTTP connection, you say, hey, by the way, I want to upgrade the HTTP connection, and that TCP connection kind of stays. The HTTP connection is upgraded to WebSocket, and all the communication then that happens between that client and server on the same TCP connection. So that's pretty cool. So what is a WebSocket? And my one single line definition is, it's a bidirectional full duplex communication channel over a single TCP connection. Now, if you want to read about the WebSocket protocol itself, then Google for this RFC 6455. It gives you a lot more details about how the protocol is defined, how it needs to be laid out, what the wire format should look like, how the connection handshake happens, all of those details. For a protocol, I think it's a very easily read protocol. You can look at it and get the meaning out of it. Typically, protocols are not that easy to understand. The other part, when people talk about WebSocket, is the JavaScript API, because most of the time you use WebSocket from your web browser. That I want to establish a connection where I want to get a server push, like a stock ticker kind of thing. So there's a JavaScript API that is defined, which can be used from your web applications or your HTML pages very easily. So how does it work? Well, I like pictures that way. So let's say there is a client and there's a server. To begin with, it's a HTTP server and an HTTP client. They're exchanging HTTP messages, so nothing different. They exchange HTTP messages. That keeps going on. At a given point of time, the client says, okay, now I'm ready to establish a WebSocket connection. So there is an explicit handshake request that goes from client to server. If the server understands that request, that okay, this is a handshake request for WebSocket, it responds back with a handshake response. So you get a handshake response back to the client. Well, how does the handshake request look like? It's just a bunch of HTTP headers, effectively. Now, HTTP headers, as you know, they need not be sorted. They can be in any order. But the key information that we are looking over here is, for example, upgrade and connection headers. Those two headers effectively say, oh, this is a connection upgrade request to WebSocket. In addition, there are this sec WebSocket key, which is a unique key that is generated to basically ensure that this is generated by the underlying WebSocket framework or WebSocket implementation in the browser. Now, once a WebSocket capable server receives that request, it responds back, essentially echoing the head. Well, first of all, it says, okay, I'm switching protocol. So I'm no longer talking HTTP with you now. Basically after this message. Then it's going to say, oh, now I'm echoing the header back. This WebSocket upgraded. Okay. So once the connection is established, and at that point, once those headers are echoed back, and there are a lot more details on how the protocol establishment is done. But once that is established, the client and the server, they are no longer client and server. They are both essentially peers. So for simplicity, we'll say just client peer and a server peer. Okay. Now, how do they communicate with each other? Now, once the establishment is done, once the connection is established, the TCP connection is holding on. The connection stays solid. There is a callback handler that could possibly be called on the server side, and on the JavaScript side, there is a callback handler which gets called. That, oh, connection is open. Do you want to do something about it? Initialize resources, send some information, log something, display something in the developer tools console. The server may send a message. The order is completely independent. It's full duplex. So anybody can, once the connection is established, anybody can send a message. So in this case, server is sending a message, and so client gets an on message callback. Server sends another message. Notice I'm specifically saying server sends the first message because by default we assume, hey, client is going to initiate the communication. No, in this case, server can very well do the initiation, but it's just a message. When server sends a message, does not mean it's expecting a response back. There is no concept of like HTTP error code or 201 or anything like that. It's just a one-way message that the server has sent to the client. Now, client may try to send a message and it does not go through for some reason. Then an on error callback handler is being called. Finally, client sends a message, and on message is called. Either client or server can initiate the termination of the connection, and in this case, server is initiating. So on close is called, and there are error codes and there are status codes in on error and on close which are being thrown. So for example, in this case, if server properly initiated the connection closing, then on close would actually specify that, oh, the server initiated this connection. Or if it happened because of TCP timeout, for instance, then the error code would indicate that. But at that point of time, effectively, your client and server are disconnected, and all of that connection is lost. So think about it. HTTP is by nature a stateless protocol. This is a stateful protocol, but stateful over TCP though. So if you take a look at it, the JavaScript API that exists now here, this is literally from the WebSockets API. This is the page where it is. This is still a technical recommendation. Well, it's a candidate recommendation at this point. Now here is saying some of the state elements that can be maintained. The fun part is where you say the callback handlers. We talked about on open, on error, on close callback handlers. So in the API or in the application, when you're writing your JavaScript, there you say, I'm going to call a new WebSocket, and then on that WebSocket object, you can register your callback handlers. Now WebSocket can send text data, which is using DOM string, or binary data, which is using any of these data types. So effectively, these are overloaded methods, and I'll show you a usage of how to do WebSocket communication. How many of you use Internet Explorer as your primary browser? Okay, I thought so. Well, sometimes I've seen hands going up. My company wants me to use it, so it's okay. I feel for you, but generally that's not the case. And the reason I ask is because this is a cool website to know. caniuse.com/websockets. I'm just using it for WebSockets, but you can use it pretty much for any web technology to see how long that technology, or what's the status of that technology in a variety of different browsers. So for example, here, well, you ideally go to caniuse.com, pick a technology, and then in this case, I'm using WebSockets. So here is showing me that IE supported WebSockets only since browser version 10, nothing before. So there is no WebSocket support. And still IE 7, 8, and 9 are pretty heavy deployments, across the industry. So that means if you build a WebSocket application, you need to be aware that it may not run. That support needs to be there in the browser itself. So if your clients or if your customers are using that older version of IE, I guess you're stuck of not using WebSocket. I'll talk about a little bit how you can work around that. But otherwise, the modern browsers, so Firefox, Chrome, Safari, I call them as modern because they are pretty much up to date on the standards. They have their own quirks, but most of the standards are supported, and they have supported WebSockets for a while as well. All right, so let's talk about Java API for WebSocket and how it enables a simple WebSocket application development. Java API for WebSocket, it basically provides an API for doing a server endpoint and a client endpoint. Now, in a WebSocket, we talked about a single client and a single server, but it's not a peer-to-peer communication. The model is really like a wheel. You have at the center is a server, and all the clients are at the edge of the wheel. So if a client has to talk to another client, then the client essentially sends a message to the server. Server then figures out, or you build your application logic on the server, whether it needs to do broadcast, unicast, multicast, whatever it needs to do. It needs to be defined at the server itself. Literally think of WebSocket as a very low level protocol, where you don't provide, there is no intelligence. Any sort of intelligence needs to be kind of built into your application's code itself. But effectively, if you want to build a server endpoint, you take a POJO, put a add server endpoint annotation on it, and that becomes a server. Or if you take a POJO and put a add client endpoint annotation on it, and that becomes a client endpoint. There is, of course, a way by which you can do a programmatic endpoint. So annotated endpoint is a lot of default conventions, but if you want to override them, then you can use programmatic endpoint. For example, we talked about the connection handshake that happens, or the negotiation that happens. If you want to get access, a little bit more detail about that handshake, on how that handshake is being done, what are the HTTP headers that are being exchanged, you want to manipulate them or alter them, you can do that if you're doing the programmatic WebSocket endpoint. The Java API also defines lifecycle callback methods. So just like in JavaScript you have on error, on open, on close, and all those methods. You just leverage those methods, and you define similar methods in the Java API as well. And of course, this is defined as part of Java EE 7, so it provides integration with the rest of the Java EE technologies. So we're not going to focus on that today, though. So here is my very simple annotated endpoint. I have import javax.websocket.star. That's the package name, first of all. Very trivial POJO, public class hello bean. And I want to make, this class has one method, takes a string parameter, returns a string by concatenating the parameter. Now, if I want to make this as a WebSocket endpoint, I just add the add server endpoint annotation. That's it. No deployment descriptors, nothing is required. And being a server, you need to specify the URI where you are listening for those requests. So that's where you say /hello, and that's where the requests are being listened. So in terms of WebSocket annotations, there is a server endpoint which turns a POJO in server, and there's a client endpoint annotation which turns a POJO in a client endpoint. Okay. There are method level annotations. So just like we have on message, which basically identifies the method that needs to be called whenever it receives a message. There are on open, on close, and on error annotation. These are intentionally by design kept very similar to the one in JavaScript, so that you can at least mimic the code. To each method, you can also specify a variable part of the URI. You can start mapping it. So just like REST endpoint, you have a variable template here, and you can say, I want to get that template and map it to a method parameter, and that's what you use path param for. So if I look at server endpoint itself, the annotation, which is the primary annotation by which I make a POJO into a server endpoint, there are a few attributes that I can specify. The first, of course, is the value, which is what is the URI where the server endpoint will be listening. Now, a server endpoint can receive a text or a binary data, but every time you receive text and binary, you may not want to deal with it in a raw format. So what you want to do is you may want to convert it into a domain specific object, say graph or image or a student or whatever your entity type it is. Now, putting that logic of converting the raw text into POJO, it would be make your code ugly. Then we're not really following separation of concerns design pattern. So in order to do that, WebSocket defines this concept of an encoder and a decoder. So what you do is you define encoders and decoders as a class names in your server endpoint, and those encoders and decoders essentially encode and decode to and from text to the POJO. So you receive a POJO, you receive text. Now the and decoder will say, hey, I know how to decode that, and I know how to decode that. I'm going to take it and decode that into a POJO. Or if you want to send it out on the wire, then you still deal with the POJO object, and it says how I know how to encode it into a string, and I'm going to do that. So the classes will do the conversion for you, but you just specify them as part of your server endpoint attributes. Now, WebSocket also has this concept of a sub protocol. It's a very low level protocol, but you can build other protocols on top of it. So for example, you can do pub sub, or you can do a Jabber protocol on this. And that's where you start defining sub protocols that are potentially supported in your particular implementation of the server. Now, by default, these sub protocols are defined in a public registry, but you can have a custom application specific protocol as well. So here is a simple look at my chat server. So this is a chat bean. I have a server endpoint, which is where, and they specify the URI where the chat endpoint is listening. Now I have a static set. By default, for every class, now I mean it's a stateful protocol. So every time a client connects to an endpoint, a new instance of the class is created and associated with that client. But if you want, if you want any state sharing, you got to make it static in that case. So in this case, I'm making it static. I have on open, on close, on message callback handlers. In on open and on close, I'm having one parameter each. All I'm saying is every time a client opens a connection with this server, add that client to the set of peers, and similarly remove it from the peers when the connection closes. So what that gives me is a set of connected clients at a given point of time. And then broadcasting the message is pretty straightforward. All I need to do is I just need to iterate over all the peers and say broadcast the message. And this is where I'm receiving the message anyway. Now, following the API itself, I can simplify it. I don't need to maintain the state myself. I could say every time I get a message, this is the method that's going to be called. String is my payload. Session is a conversation between the client and the server. It basically stores the state. I can say, give me all the open sessions, and then I can broadcast it. So instead of me maintaining the state of all the open clients, I would let the WebSocket runtime do that for me. All right, so let me show you a simple sample here. So if I go here, for example, and you can, this is a publicly accessible URL. If you go to my wildfly-miles2go.orhcloud.com, if you go there, so I have it here, and I'm going to open up another window here, which is the incognito window. Okay. All right. So here we are. Now I'm going to join as me here. Okay. I'm going to join here. So as soon as I join, this users list is automatically populated. I did this at Belgium last year in November. There were about 800 people in the room, and as soon as the URL went live, there were all sorts of messages, all sorts of users who were joining, and the screen was flooded. But anyway, you get the point. So here, if I click on this, it shows me the list of users. Now if I minimize this guy here. So here, for example, if I'm joining as Duke, I click on this, it joins here, and then it shows up here. So there you go. There's somebody joining over here. Now, I'm sort of graphically challenged, so it's not a very fancy UI, but you get the point. So now here, if I want to say a message here, so I'll say hello, and I'd say chat. I say chat, it says Duke is saying hello, and the Duke saying hello shows up here. I go in the other window, I can say howdy, and I can say chat, and it says howdy. Very simple interface, but that's the whole point, because the goal here is to talk about the technology than anything else. If I show you the code behind this, so my chat server is exactly what I showed in my code earlier. It's very straightforward, nothing fancy in there. Server endpoint listening at this chat URI. This is the on message annotation. and it's just broadcasting to all the clients. Okay. If I look at my WebSocket.js, that's where all the fun is happening. Now, when I say new WebSocket, that's where I'm initializing the new WebSocket connection. And that's where my browser runtime layer kind of kicks in and says, oh, you need to establish a new browser connection. I'm going to do the protocol handshake and everything for you. Here is where I'm defining my on open, on message, on error callback handlers. And then everything else is just straightforward JavaScript. So as you can see, it's a very natural, very clean programming model, nothing fancy over here. Now we talked about the custom payloads part of it. And so there were decoders and encoders attribute. And how do you do that? Well, here in this case, I can specify the decoders and encoders attribute. So let's take a look at how my decoders and encoders would look like. So in this case, I could have a text decoder, for example. And here is saying, oh, my message decoder implements decoder.text. I got two messages here, which takes the string and converts it into my decoded class, which is my message in this case. And similarly, I have a text encoder, which takes my message and converts it into string. Because effectively on the wire, what goes is string or binary data. But in the business logic, you may want to deal with domain POJOs. And so that mapping is easily done by encoders and decoders. You are certainly allowed to have binary decoders. And in that case, instead of string, you become byte array. Or you can even use byte buffer as well. So here is another sample that I would like to show you on how to use encoders and decoders. So let's say there are two browsers running across the internet. Whatever I click on one browser automatically shows up on the other browser as well. So think of it as a collaborative whiteboard. Okay. Once again, I click and I click and whatever I click on one browser shows up on the other. Okay. Let me show you this sample live here. Now this is running on my local box, so you won't be able to play around with it. These are a bunch of samples that are existing on the GitHub project. About 35 plus samples that shows you different ways of using WebSocket. So if I'll take you there. But before that, let me bring up my whiteboard here. I'll copy the URL, come back here. Okay, so this is my sort of collaborative whiteboard here. Again, you can see I'm sort of not the most graphically intense person, but I get the job done. So whatever I click here, it shows up on the other browser. Okay, and similarly, I change the shape and the color here, and whatever I do here shows up on the other browser. Okay, now I could possibly go in an offline mode that, okay, I'm not connected anywhere. I can still continue to play around with it, use different shapes and colors. Okay, and nothing is getting transmitted. But then I can say, hit a snapshot, and then it sends everything over here. So let's see behind the wire what's really happening to make it happen. Now, this is just showing as a collaborative whiteboard, but think about this as a collaborative game that you're playing across the internet on a browser. Okay, so let me refresh the page here. Refresh the page here. Okay, so let's do something here first. I clicked somewhere on this collaborative whiteboard. So effectively what you're seeing is in the developer tools is sending a JSON structure. The JSON structure says shape square, color red, and coordinates, which are X and Y coordinates. Now I create that JSON structure, send it over the wire to server then transmits it to all the clients. And in this case, this client reflected it. On the other side, if I go here, change shape and color, and I click here, then I say received that JSON structure. Okay, so this is still text. Now I make some changes, and then I say snapshot, now it's receiving a binary array over here. Okay, the developer tool shows that. So let's look at the code behind this to see what's happening here. So here I have my whiteboard with the server endpoint annotation and the encoder and decoder. Okay, if I look at my encoder for or decoder first rather, in decoder I take my string and I convert it into figure. Whatever API I want to use. It's my JSON. I know it's coming as a JSON. I just process it, convert it into JSON, and similarly in my encoder, I'm taking my figure object and converting it into string. And whatever API I want to use is completely up to you. And then I have the broadcast method here. Name doesn't matter really. All that matters is the at message on message annotation. And once you do that, then it iterates over all the clients and then sends it over. Now you can optimize it where you can say, oh, don't send that same coordinates back to the same client. And that's what line 47 is telling you, that, oh, if you are the same guy, don't send it back to yourself, but broadcast to anybody else. And that's where you start building your application specific multicast, unicast kind of protocols. Who do you want to send it to? Or the point being, WebSocket is a very, very low level protocol. Any application specific logic needs to be baked into your application code. The WebSocket code is very, very similar to the one that I showed earlier, so I'm not going to go into that. The code for this is available on this GitHub project, and I'll share the slides as well. Now, you may want to, we talked about client endpoint. So how do you do Java client endpoint? Well, in this case, here I have a POJO. So I just specify at client endpoint annotation on it, and I can specify which message needs to be called when the client endpoint receives a message. Now remember, we talked about client does not have a URI because client is just connecting to a server, but it needs to have the capability to receive messages from the server. So that's why the annotation is required, but there's no URI that needs to be specified. So in this case, what you will say is, oh, I'm going to initiate a WebSocket container in the client, and then I'm going to say, take this client class and connect to this WebSocket endpoint. Well, instead of saying hello, it should really be the complete URI, which is the ws:// host port, context root, and the URI. So let me show you a simple sample for that as well. Okay. Now this I'm running as a simple desktop application. It's a simple JavaFX application. Okay. And again, you can see my Google Docs emulator is sort of graphically challenged, but it shows the concept. So whatever I type here, it automatically shows up in the other window as well. And similarly, whatever I type here shows up in the other window. So if I say Riga is cool, it just shows up in the other window. So you get the point that how you can have WebSocket capability not just in a browser-based application, but you can have your client endpoint using it in a Java SE desktop application as well. Now the server for this, of course, is running, like in this case, I'm using WildFly, which is where my WebSocket server is running. So once again, these two client applications, they're really talking to the server, and then that's how they're communicating. One of the typical topics people ask about is how do I secure my WebSockets? So there are a few ways by which what I've seen, people are securing WebSockets. Now by default, when you're building a WebSocket connection, you say ws://. That's the URI scheme you use, and that's done over HTTP. So that's plain simple text HTTP. Now you may be able to look at the HTTP headers, but once it's WebSocket, then you require sophisticated network snooping in order to snoop those packets. But there are certain things that are built into WebSocket. The first one is origin-based security model. remember when the HTTP or the WebSocket handshake happens, as part of that there is an origin header, so that the server exactly knows where the request is coming from. So the standard HTTP origin security model applies to WebSocket as well. Second is, there is a, we talked about, remember there's a, in the HTTP or the WebSocket handshake request, there is a sec key, sec WebSocket key. Now if you're using XML HTTP request, then you can, when you're talking to a server at that point of time, you can generate any random HTTP header, not this header. If you try to generate any of the sec WebSocket key, it will just ignore it, or it will just give you an error, because those errors can only be generated by browser implementations. So you can't really fake those headers, and without those headers, WebSocket request is not valid. So there is some sort of built-in security in the protocol itself. Another way I've seen is, people are, well, this is what the WebSocket specification itself specifies, or the JSR 356 specification says. Because WebSocket effectively is a URL. Eventually you take this class, package it as part of a WAR file, and then when you package it as a WAR file, in the web XML, you can specify your URL constraints that, oh, this so-and-so URL is protected with so-and-so constraint, or so-and-so security constraints. The same security constraint apply to your WebSocket as well. So you could say anybody who tries to access slash WebSocket endpoint, you need to pop a window like a file-based realm or a LDAP-based realm. You can tap into that and then make sure that authentication automatically happens. And last but not the least, instead of using WS, which is over plain HTTP, you can use WSS, which is over HTTPS. So those are some of the ways that I've seen people are using to secure their WebSocket. Another option that I've seen is where, think about the flow. You're doing HTTP messages and then you say, oh, now I'm going to go do WebSockets. So by the time you actually get to, when you say I'm going to do WebSocket, that's effectively a JavaScript call that's done from your HTML page. So before you get to that stage, do your authentication authorization before that using standard web principles. Be it REST, be it form-based login, whatever it is, do all of that before you initiate your WebSocket connection. So there are a lot more details on how do you do user-based security, and how do you do form-based login, specifically with WebSockets on that scenario on my blog over here. On the TLS-based security, again, there are more details on my blog, both of these are available. A typical question that people ask is, how do I load balance WebSocket? Well, that's the point. WebSocket is a stateful protocol. Okay, so in case of HTTP, it's a stateless protocol. You have this concept of a sticky session that I got 3 machines, I got a load balancer, request comes into the load balancer, it knows which server I'm serving the request, it keeps sending it back to the same guy. In WebSocket, there is no such concept of a sticky session. There is no horizontal load balancing of WebSocket. The only way you balance load balance WebSocket is by vertically load balancing it. And that's a fair deal, because with HTTP, the constraint comes out in, how many ports can you open really, how many can it handle, because it has to manage all that session data and process all those HTTP headers. With WebSocket, really the only limitation is how many underlying sockets or how many underlying file descriptors can be opened. Typically the number of sockets on a machine are a lot lesser than the number of file descriptors. So for example, on a 64-bit Linux, the hypothetical limit is 4 million. Okay. Internally, we have done benchmarks where running up to 80,000 concurrent connections of WebSocket has not been an issue. So that's sort of the numbers we have seen. And I'll show you another benchmark numbers, which was very pleasantly surprising for us too. So the way you do that, reverse, the way you do load balance WebSocket is again standard techniques. So you do either reverse proxy or you do only vertical scaling, and there is of course no session replication. How do you do vertical scaling? That details are again available on my blog over here. One of the questions also people ask is, how does it compare with REST? REST is a panacea. It solved all my world problems. But now WebSocket is coming in. Should I replace REST with WebSocket? That's not true. REST is a very well-defined vocabulary: get, put, post, delete, verbs, all that stuff is in there. That's not there in WebSocket. WebSocket is a very low-level protocol. Everything on top of it needs to be built as part of your application. So what I did is I wrote a simple echo endpoint for WebSocket and REST. And then I said, okay, I'm going to keep the number of messages as 1,000, and I'm going to increase the payload, from 1 kilobyte to 2 kilobyte to 5 kilobyte to 10 kilobyte, sort of a usual payload of a web request, and see how they perform. And here is showing how much time it took for REST to process in the gray blue bar, and then orange is showing how much time it took for the WebSocket. So you can see WebSocket is significantly lower than the REST endpoint, and all I'm increasing is the payload. Another alternation to the data is where I'm just keeping the payload constant, but I'm increasing the number of messages. And here the distance is a lot more stark, because guess what? Where most of the cost in the HTTP message is coming is the generation and the consumption of the headers and doing that HTTP header processing. But once that is done, the payload is a fixed size. Payload is whether WebSocket or REST, doesn't matter really. It's more about consuming it and acting upon it and doing something with it. So in this case, what you're seeing is this is almost like 10 times the difference, and this is about 10,000 messages that are being sent and a constant payload of 1 kilobyte. So this is something useful to take a look at it. The source code again for all of this is available on the WebSocket repo that I talked about. So you can check out, run it by yourself and send PRs. That's over here. Another question that people generally ask is, how does it compare with server sent event? Now, server sent event are part of HTML5 specification. WebSocket is a full duplex bidirectional communication channel. Server sent event are good where client doesn't have to send any information to server, but only server needs to push information. And that's a valid use case. Like stock ticker is a perfect example. You wish you can influence the stock somehow, but it's only the server that is pushing information to you. So in that case, these are server push notifications. Just like your WebSocket, they have this event source API, JavaScript API, and they have their own message callbacks as well. Once you register that API, the server sent event endpoint on the server side is generating events which are following this particular MIME type. So let's compare the two, compare and contrast. Okay, so WebSocket and server sent event. Now WebSocket, well, first of all, server sent event is a very over your regular HTTP protocol. WebSocket, as a matter of fact, once the connection handshake is completed, it's a completely different protocol. There is nothing, absolutely nothing HTTP about it. Any of that protocol you need to build by yourself in the application. Server sent event is only server push. If the client needs to communicate with server, that has to be out of the band. In case of WebSocket, is full duplex bidirectional. So client can send a message to server, server can send a message to client. In WebSocket, you require native support in the web browser. So if you want to use WebSocket in IE 7.8, you can do that. IE 7.8.9, it won't work at all. I mean, there is no way to backfill it. And that's where what you do is you use framework like Atmosphere or Socket.io, or the bunch of frameworks that are available. What they do is they look at the browser where your application is running. Oh, the browser is 7.8.9, so WebSocket is not going to work. They fall back to long polling, for example, or polling, and you can configure what are your preferred choices. And if the browser does support WebSocket, then they just start using WebSocket right away as is, without you knowing it. And let's say in a year or two later, your client actually does move to the newer version of the browser, then your application doesn't have to change in that case. So that's something to keep in mind when you're designing applications using WebSocket. With server sent event, that is not required to be supported in the browser itself. So you can polyfill that by adding your library to the application itself. Server sent event is a very straightforward protocol. WebSocket is not that straightforward when you look into packaging and formatting and things like that. Another pain point of WebSocket is if you are, if the connection is lost, it's lost. You at the best you get is a on close or a on error callback handler, and then you act upon it. Oh, by the way, connection is closed. Now I'm going to initiate it. In server sent event, there is inbuilt support for how you can do the reconnection automatically. Okay. WebSocket, generally could be a mess if you're using, firewalls, proxies, all those things. Some of the proxies and firewalls could be very picky, and they may say, hey, by the way, I only expect HTTP headers. Your working port 8080 is good, but I don't understand this, what's happening, and I don't see the HTTP headers going back and forth, so I'm going to block the traffic. With server send event, no change is required. Server sent event is text only, and we talked about how WebSocket is text and binary. In WebSocket, there are predefined message handlers: on open, on error, on close. A subset of those exist because there is no on error, or there is a on message callback handler in server sent event, but you can define arbitrary custom handlers as well. Typically for debugging WebSockets, I showed you one tip which was easy, like Chrome developer tools. Pretty much all the browsers have similar tools. You can start looking at your live WebSockets. So here, for example, I'm showing you in my Chrome developer tools, I can filter here. I can say show me only WebSocket request, and here is showing me the header request and response that's going back and forth. And then in addition, I can actually see the WebSocket frames that are being exchanged back and forth as well. Okay. If you go to Chrome Net internals, there is also a capability by which you can say, oh, show me all the live connection and as the traffic is being exchanged. So you can do that in Chrome as well. Or if you want real on-the-wire data, and that's where you use Wireshark. So with Wireshark, it's like a network sniffer, which used to be ethereal basically. So you can just snoop the data and it'll show you the exact traffic. All right, all the material, all the samples, everything is linked from this GitHub repo. By all means, feel free to use it, share it. And that's my last slide, and time's up. Thank you.